Students, chapter 1 relation function, exercise number 1.2. See the question number 3. A relation R is given by the set x comma y such that y is equal to x plus c is the relation, right? And x belongs to the element 0, 1, 2, 3, 4 and 5. Determine its domain and range. We want to find what is the domain and range. We know that the domain is the first set element, the range is the mapping elements, right? Let's see the solution. The given relation is y is equal to x plus 3. The given relation is y is equal to x plus 3. The set x is given as x belongs to the number 1, 2, 3, 4 and 5. Now apply the value of x to find the value of y. Here x is equal to 1. Sorry, first number is 0. Here x is equal to 0. Then what is the y value? Then y is equal to 0 plus 3. Then 0 plus 3 is nothing but 3. Then the order pairs are 0, comma 3. The element 0 is mapping with the element 3, right? And then if x is equal to 1, y is equal to 1 plus 3 is equal to 4. Then x is equal to 2. Y is equal to 2 plus 3 is equal to 5. X equal to 3. Then y is equal to 3 plus 3 is equal to 6. And then x is equal to 4. Y is equal to 4 plus 3 is equal to 7. And then x is equal to 5. Then y is equal to 5 plus 3 is equal to 8. See all the x values are the domain, and then the mapping elements, the relation to the x is the range of the elements. Here I draw the arrow diagram to represent the relation. First see the x value is 0, 1, 2, 3, 4, 5, and then this is the first set, and then function of x is the 3, 4, 5, 6, 7, 8. See the mapping elements from 0 to 3. First I write the relation R is equal to 0, comma 3, and then 1, comma 4, 2, comma 5, and then 3, comma 6, 4, comma 7, and then 5, comma 8. These are the relation of this term. Now we want to write what is the domain and the range. See here one is mapping with 2, 3, 4 and 5. The domain is the first set element is called the domain, right? So the domain is equal to the first set element, all the x values are the domain, 0, 1, 2, 3, 4, 5. Now we want to write the range. Range is differs between the codomain. Whatever the elements having the mapping with the elements. Mapping elements only we call as a range. The range of R is equal to wherever it is mapping. Only that particular elements are called the range. Here I have mentioned in a arrow diagram. So only the mapping element is 3, 4, 5, 6, 7 and then 8. This is the range of the sum. Students, let's see the exercise number 1.2, question number 4. Represent each of the given relations by an arrow diagram, a graph and a set in roster form wherever it possible, right? Let's see the first Roman number, x comma y is the ordered pair, and then the function is given as x equal to 2y. Here x belongs to 2, 3, 4, 5 and y belongs to the elements 1, 2, 3, 4. First we want to find out the ordered pair of the set, then we have to write the terms in the as given the arrow diagram and then graph and set ordered pair, right? Solution. See the given function is given as x is equal to 2y, right? Here if you apply the y value we get the x value, right? Now we take the y is equal to y belongs to what are the elements? We have 1, 2, 4, right? They take us 1, 2, 3, 4. So now we have to apply the value of y to find the x value, right? When y is equal to 1, first element, I apply that value, y is equal to 1, then we get the x is equal to 2 times of 1 is equal to 2. Now we want to write the ordered pair for this means, see, x is in the first element, y is in the second element, right? Then the ordered pairs are 2, 1. Right? X term is first and then y term is second. Then the ordered pair is 2, 1. Then when y is equal to 2, then x is equal to 2 into 2. In the place of y, apply the value 2. Right? 2 into 2 is 4. And then when y is equal to 3, then x is equal to 2 into 3 is equal to 6. When y is equal to 4, the function is x is equal to 2 into y. The y value is 4, we get 8. Now we write the ordered pair here. It is 8, x value is the first element, x, y. So you must write the x value as first element and then y value as the second element. 8, 4 here, 6, 3 here, 4, 2. Now first we want to write in an arrow diagram, represent the given function in the form of arrow diagram. Let me take as the two set, the first set and then second set. The first set is given as x and then second set we take as y, right? And then first set elements are 2, 3, 4, 5. Here we have 1, 2, 3, 4. See, the ordered pairs 2 is mapping with 1. So the image of 2 is 1. And then the image of 4 is 2. The image of 6, there is no element, right? There is no element 6, there is no element 8 will be there. So only we get this 2 arrow diagrams only for this relation. Next, we want to represent in a graph the same relation. We have to represent the graph B. Let me take it as x-axis and y-axis. Let me take the values here, x value and then y, this is origin, x dash and then y dash. See the x points we have 2, 3, 4, 5, right? So let me take as 1, 2, 3, 4, 5, 6, 7 and then y values we take as 1, 2, 3, 4, 5, 6. Now we want to find the plotting points of this. Means 2, 1. 2, 1 is in x-axis 2, y-axis 1. This is the point, right? So this is 2, 1. And then 4, 2. 4, 2. Here is the point 4. And then 2 is here. 4, 2. So only we have the relation with the 2 and 1, 4 and 2. It's enough to mention that graph, right? Next, last we have to see that a set in roster form. The set in a roster form. We have write the set in the roster form means. Then let me take this R as the relation. We have to write all the sets. Wherever it has a mapping elements only how to write 2, 1 and then 4, 2. By the relation we have find out that all the terms, but here only mapping elements are 2 and 1 and 4 and 2 only the mapping elements. So for this what are the elements in the mapping, that element only how to present in the graph and then you have write in the set order also. Students, today we are going to see the first chapter relation and function, exercise number 1.3, question number 3. Given the function f from x2 is given as x square minus 5x plus 6. Evaluate the function of minus 1, the function of 2 of a, and then function of 2, and then function of x minus 1. Let's see the answer for this. Solution. First, the given function is f of x. We take that as the given function. The function is x square minus 5x plus 6. Now we want to find the function of minus 1. For first Roman number, f of minus 1. In the place of x, I am going to apply the value minus 1. So minus 1 whole square minus 5 into minus 1 plus 6. Then minus 1 whole square is minus 1 into minus 1. We know that minus into minus plus, and then 1 ones are 1. And another condition, wherever we have a negative value with even power means we get only positive value, right? So 1, then minus into minus plus 5 plus 6. Sum of this term is equal to 12. Then second Roman number, f of 2a. Right? In the place of x, I am going to replace the value 2a. Then 2a whole square minus 5 into 2a plus 6. Now, if you square this term, we have a plus ab whole square means we want to square both the term a square and b square, right? So, when you square this, we get 2 square is 4 and then a square. Minus into plus is minus, 5 2s are 10a plus 6. Furtherly, we cannot be simplify this. Then we see the third Roman number. Function of 2. Here the function you are going to replace the value 2 square minus 5 into 2 plus 6. Then 2 square is equal to 4 minus 5 2s are 10 plus 6. Here 4 plus 6 is 10. 10 minus 10 is equal to 0. Then fourth Roman number, the function of x minus 1. See here in the place of x, I am going to apply the value x minus 1. Here we have x minus 1 whole square minus 5 into x minus 1 plus 6. It is in the form of a minus b whole square form, right? So we know the formula a square minus 2ab plus b square, that is a minus b whole square is equal to. Now you are going to apply the formula here. In the place of a is x and in the place of b is 1. So x square minus 2 into a into b means 2x plus 1 square is nothing but 1. Now you take the minus 5, you have to multiple each and every term. So minus into plus is minus, 5 into x is 5x, minus into minus plus 5 ones are 5 plus 6. Now here we have only one term is x square, so write as it is. See here we have two terms, both having a negative symbol. Put the negative symbol as it is and add the coefficient of x. 2 plus 5 is 7x. Here we have constant 1, 1 plus 6, 1 plus 5 is 6, 6 plus 6 is 12. So here are the function of all the terms. Students, let's see the exercise number 1.3, question number 5. First is the question. Let f of x, the function is given as 2x plus 5. If x is not equal to 0, the condition, then find f of x plus 2 minus f of 2 divided by x. We want to find out the value of the function, right? Solution. First we want to take the term what is f of x plus 2 and we have to find what is x minus f of 2. Then we subtract and divide by x. The function is f of x is given as 2x plus 5. Now we want to find the function f of x plus 2. See, in the place of x, I am going to replace the value x plus 2. X plus 2. So, here also we have to put x plus 2 plus 5. So, in the place of x, I am going to replace the value x plus 2. Here we have x. So, in the place, I am replacing x plus 2. Now, multiply this term. 2 into x is 2x plus 2 2s are 4 plus 5. Then 2x plus 9. That is function of x plus 2. Next we want to find out what is the function of f of 2. See, f of 2, in the place of x I am going to apply the value 2. Here also we have to apply the value 2 into 2 plus 5. 2 into 2 is 4. 4 plus 5 is equal to 9. Now I take the term f of x plus 2 minus f of 2 whole divided by x. Now this term is equal to, what is the value of f of x? F of x plus 2 we have find out here. It is 2x plus 9. So I apply here value 2x plus 9 minus, and then f of 2 we have find out that is 9. 9 divided by x. Here plus 9 minus 9 both are cancelled. So we get 2x divided by x. See, here x and x will be cancelled. So we get 2. So the value of f of x plus 2 minus f of 2 divided by x is equal to 2. Hi students, today we are going to see the exercise number 1.3, question number 6. A function f is defined by f of x is equal to 2x minus 3 is the given function. Now we want to find out the first Roman number we want to find f of 0 plus f of 1 divided by 2. For this first Roman number, we want to find out what is the function of 0 and the function of 1. The given function f of x is equal to 2x minus 3 is the given function. Here I am going to apply the value. First we want to find out function of 0, right? In the place of x, I am going to apply the value 0. That is 2 into 0 minus 3 is equal to 2 into 0 is 0 minus 3. 0 minus 3 is equal to, we get minus 3. The function of 0 is minus 3. Next we want to find out f of 1. Now f of 1 is equal to, in the place of x, going to apply the value 1. 2 into 1 minus 3 is equal to, 2 into 1 is 2. Minus 3 is equal to 2 minus 3 is equal to minus 1. Right? Next we want to find out f of 0 plus f of 1 divided by 2. F of 0 plus f of 1 divided by 2 is equal to, now we have find out that the f of 0 and f of 1 value is minus 3 and minus 1. Here we have minus 3, we have plus of minus 1 divided by 2. If you remove the bracket here, you have to multiply the symbols, right? Next, minus 3 plus into minus 1 divided by 2 is equal to minus 3 minus 1 is equal to minus 4 divided by 2. Divide this 2 ones are 2 2s are. So the value is minus 2. Next we see the Roman number 2. See the Roman number 2. Find the x such that f of x equal to 0. F of x is equal to 0. The function is f of x equal to 0. We want to find the value of x. The given f of x value is equal to 2x minus 3 is the given value. So in the place of f of x, I apply the value 2x minus 3 equal to 0. Then 2x is equal to, I take this minus 3 to another side. 2x is equal to, we get 3. Then x is equal to 3 divided by 2 is the value of x. Next we see the third Roman number. Find the x such that f of x is equal to x. The third Roman number is the function of x is equal to x. That is the given term. So we know that f of x, the function of x is given as 2x minus 3. So we are applying the value 2x minus 3 is equal to x. Now I take this x to this side and minus 3 to right hand side. So 2x, if it is plus symbol means you have to change to negative symbol, minus x is equal to, here we have negative symbol, if you take another side means we get plus 3. Then 2x minus 1x is equal to x, then x is equal to 3 is the value, the function of f of x is equal to x, right? Now we see the fourth Roman number. Here the fourth Roman number, find x such that f of x is equal to f of 1 minus x. The fourth Roman number is f of x is equal to f of 1 minus x. Now see that f of x is given as 2x minus 3. I write the given function as it is 2x minus 3. Now f of 1 minus x means in the place of x you have to replace the value 1 minus x. So 2 into 1 minus x minus 3. The two terms, the two functions are equal, that is given. Now we want to find the function, right? 2x minus 3 is equal to, multiply this 2 inside, 2 ones are 2 minus 2x, right? Minus 3. Take the variable term one side and constant term to other side. If I take this 3 to other side, we get 2x already here. Here we have minus 2x. I bring to this side, we get plus 2x is equal to, here we have already 2 and then minus 3. Now this minus 3 I take to other side, we get plus 3. So plus 3 and minus 3 both are cancelled. Then 2x plus 2x is equal to 4x is equal to 2. Then x is equal to 2 divided by 4. Reduced by 2, we get 1, 2. So x is equal to 1 by 2 is the answer. Thank you, students. Hi students. Next we see the exercise number 1.3, question number 8. A function f is defined by f of x is equal to 3 minus 2x is the given function. Find the x such that f of x square is equal to f of x whole square. See the square and the whole square differs. Now we want to take the given function f of x is equal to 3 minus 2x. F of x is equal to 3 minus 2x. Now we want to prove this. F of x square is equal to f of x whole square, right? Now I take that f of x square is equal to f of x whole square. See, this is the given function 3 minus 2x. Next we want to find out that in the place of x I am going to replace the value x square. So here in the place of x we have to square the term. So we get the value 3 minus 2. In the place of x only I am going to replace x square. Right? Next this term is equal to, see, f of x whole square, the whole term having the square. See the difference between that f of x square and then f of x whole square. F of x square means particularly in the place of x only we replacing x square. Now the whole term is inside the square. Now let me take this as it is 2x square. This is in the form of a minus b whole square, right? Is equal to a square minus 2ab plus b square. So in the place of a is 3, in the place of b is 2x, right? So a square means that is 3 square minus 2 into a place is 3 and then b place is 2x plus b square is 2x whole square. Now the 3 square is 9 minus 2 3s are 6, 6 2s are 12x plus 4x square. When you square this, we get 4x square. 3 minus 2x square. Now I take this term to another side. So totally I take the whole term to that side means here we have already the term 4x square minus 12x. I write in the order, right? Square term and then x and then constant. Minus 12x plus 9. Next I take the term to another side. Here we have plus 3. So minus 3. Here we have minus or plus 2x square equal to 0. Now here we have 4x square, here we have 2x square. Add the coefficient of x square. 4 plus 2 is 6x square minus 12. Here we have only one term, that is minus 12x. 9 minus 3 is equal to 6 equal to 0. See, all the terms are divided by 6. What do you get? If it is whole term is divided by 6, 6 divided by 6 is 1, 12 divided by 6 is 2, and then 1. So x square minus 2x plus 1 equal to 0. We want to find the value of x. Simple factorization, if you multiple, we need the value 1, and then if you add, we get minus 2. The only possibilities is minus 1, minus 1. See, minus into minus plus, right? 1 into 1 is 1. If you add these two, we get minus 2. That is the answer. Then we have to write the factors of this equation. X minus 1 and then x minus 1 is the factor of this equation. Let me take as x minus 1 equal to 0. Then x equal to 1. So, x equal to 1 is the answer of this question.